Now we will be describing an expression for energy of an electron. The total energy of the electron is the sum of the kinetic and the potential energy. Total energy is kinetic energy plus potential energy. And we are concerned with this total energy. So potential energy is the integral of Coulombic force dot dr. You will study this later in physics, that potential energy is the integral of force into dr. So this is the potential energy. So when we integrate, you must have studied this in mathematical tools, that integration comes out to be this. Now total energy is equals to half mv square minus times of minus kz e square upon r. Let this equation be first. From the relation obtained before, we know that mv square by r is equals to kz e square upon r square, because this is the centrifugal force and this is the electrostatic force, and they are counterbalanced by each other. So on manipulating this, half mv square comes out to be kz e square whole upon 2r. Substituting this in this equation, we get energy as minus times of kz e square upon 2r. Now substituting the value of r that we obtained in the previous relation, that is r is equals to n square h square upon 4 pi square m kz e square. So when we substitute these values, we get energy equal to 2 pi square m z square e to the power 4 k square whole upon n square h square. Now again separating the constants and the variables, we get 2 pi square m e to the power 4 k square h square times z square by n square. On solving this, we have a negative sign here. On solving this, we get minus 13.6 into 10 to the minus 13.6 into z square whole upon n square electron volt. So this is the energy electron volt per atom. So where z is the atomic number, as I have already told you this, and n is the number of the shell number. So energy varies from shell to shell. Now total energy we have seen in this case is negative times of kinetic energy and is potential energy by 2. So potential energy is twice of total energy. We have obtained this formula because total energy is this much and half mv square was kz e square upon 2r. So total energy and kinetic energy are just opposite in sign. Now we will calculate the velocity of an electron. So for velocity of electron, we know that mvr has to be equal to nh upon 2 pi according to Bohr. Now v comes nh upon 2 pi mr. On substituting r again in this value, we get v equals to 2 pi kz e square upon nh. Now again separating the constants from the variables, we get 2 pi k e square upon h into z upon n, that is equal to 2.8 into 10 to the power 8 z by n centimeter per second. So this is the relation for velocity. Now I was going to tell you some important relations. So Using this equation, that is equation number 1, mvr is equals to nh upon 2 pi. Now if you have been asked a question that the circumference of nth orbit is related to the Planck's constant, by which of the given relations. So I am not giving you the four options for this question. I will just tell you how to solve this. So we are given mvr is equals to nh upon 2 pi. Now taking this 2 pi here, we get mvr into 2 pi is equals to nh. So mv into 2 pi r is nh. Now if the value of n is 1, then r is the radius of the first orbit. So we have been asked the radius of nth orbit, so n has to be n. So 2 pi r is the perimeter, or the circumference of the nth orbit. So circumference is equals to nh upon mv. Now you will study this later, that h upon mv is equals to wavelength. So this comes out to be n lambda. I will tell you this relation later on, that h upon mv is equals to lambda. Till then you need to remember this. Now there are some terms associated with the Bohr's model as per energy configurations. So first is ground state. So ground state is the lowest energy state of any atom or ion. If this is an atom, this is shell number 1, this is shell number 2, this is the nucleus. So shell number 1 is the ground state for any atom, and excited state is any state other than the ground state. So ground state means n is equals to 1, first excited state. So if the electron is given some energy to jump from the ground state to the next level, then this next level will be known as the first excited state. So first excited state will be n is equals to 2, second excited state would be n is equals to 3, and so on. So this is about the energy states of an atom. Now what is ionization energy? Ionization energy. So ionization energy is the energy that has to be given for the electron to be free from the atom. So if this is an atom and this is electron from this atom, so the amount of energy that I have to give to this electron for this electron to get free from this atom signifies that the n should tend to infinity. So energy at n tending to infinity would be minus 13.6 times z square upon n square, and as n is tending to infinity, this complete value will be tending to 0. So energy at this point is 0. So whenever electron is free, energy is 0. So ionization energy would be E final minus E initial. So if the electron was in the ground state, E final is 0 minus 13.6 times z square upon 1 square. So this turns out to be 13.6 times z square. This is the ionization and potential. Now excitation energy is the energy required for the electron to jump from any particular orbit to another particular orbit. This is known as the excitation energy. And binding energy or separation energy is defined as this ionization energy, which is the energy that has to be given to the atom for its electron to be free.